In section 1.5, we're describing angle pair relationships and looking at definitions of certain types of angle pairs. The things that we're looking at today are complementary and supplementary angles, adjacent angles, linear pairs, and vertical angles, all important concepts that we're going to use throughout the entire year. Starting out, what are complementary and supplementary angles? These are a pair of angles that add to a certain number. Now, complementary angles are a pair of angles that add to 90 degrees. We know that 90 degrees is one of the most common angles that you see in real life. It's everywhere you look, 90 degrees, right? So a pair of angles that add to 90 degrees. Now these angles can be right next to each other, like you could have a right angle itself, and again marked a right angle by putting that box in the corner. It's a pretty bad box, so I'll fix that. And it would have to be two angles that make up that 90 degrees. So I could put another ray in here, and I could say that these two angles, the one marked in green here, and I'll put two arcs and mark in green, two arcs on the second angle. These two angles are complementary because they must add up to 90. I know from last section, angle addition says that these two angles would have to add up to 90. Now, supplementary angles add up to another special degree measure. If we're not talking about 90 degrees, what other angle measure is very nice to work with is 180 degrees. So supplementary angles are a pair of angles that add to 180 degrees. And I'll draw this one as totally separate angles because they don't have to be adjacent, they don't have to be next to each other. If I said that this was, say, 140 degrees, an angle that would be supplementary to that would have to measure what? Well, I need these two angles to add up to 180. So it would have to be 40 degrees, 140, and 40 would give me 180. So complementary angles, pair of angles that add to 90 degrees. Again, they can be adjacent, and which means they share this vertex and they share this side or this ray, or they can be non-adjacent angles, totally separate from each other. But again, you could have two angles. Maybe this one is 20 degrees, and if I want them to be complements of each other, another angle would have to be what to add up to 90? Well, I need 20 and 70. So again, the angles can be next to each other. They don't have to be adjacent, though. Complementary and supplementary. Oh, we say one angle is a complement of the other, or one angle is a supplement of the other. We'll see that right here. Oh, sorry, one more example. First, an example where we have to name a pair of each type of angles. Can you find a pair of complementary angles? Complementary angles have to add to 90 degrees. Take a look in the picture here. Can we find two angles that add up to 90? Well, how about 41 and 49? So I just have to name those angles. I can't just say angle G here. I would need to name with three letters. So how about F, G, K? That would be talking about this angle right here. Angle F, G, K. And now this angle, on the other hand, I can just say angle K. I can just name by the vertex. It's the only angle there. Complementary because 41 plus 49 would give me 90. Can I name a pair of supplementary angles? These are two angles that add to 180. Well, these two do not add to 180. That would be what, 172? But if I look at 49 and 131, these two add up to 180. To name this angle, I would need three letters, vertex letter in the middle, so how about angle HGK? And again, I can name this one just angle K. Just vertex letter, it's the only angle at that vertex. And finally, name a pair of adjacent angles. The word adjacent means next to, meaning I need two angles that share the same vertex and share a ray. These two angles here would be adjacent angles because they share vertex G and they share this ray GK. So to name those, I need three letters. How about angle FGK? That would be the 41 degrees here. And to name this angle, how about HGK? Angle HGK. Next example, we have that word complement and supplement. Here we are given that angle 1 is a complement of angle 2. What does that mean? It means that angles 1 and 2 are complementary. Remember that complementary means they add up to 90 degrees. So if one is a complement of angle 2 and angle 1 is 17, I need to find the measure that would add with 17 to give me 90. In other words, I'm doing basically 90 minus 17. The measure of angle 2 then would have to be 73 degrees. 73 and 17 would add to 90. In the next example, given that angle 3 is a supplement of angle 4, and measure of angle 3 is 119, find the measure of angle 4. So I need to know the definition of the term supplement. It means the angles are supplementary, which means that they add to 180 degrees. So if I know measure of angle 3 is 119, and I need to figure out angle 4, I'm going to take 180 minus angle 3, which was 119. What would the measure of angle 4 have to be so that those two could add up to 180 degrees? Well, it'd have to be 61 degrees. So just looking at the terminology, when you say angles are complements of each other, they add to 90, or supplements of each other, they add to 180. Using complementary and supplementary again in examples. In this situation, the purple dotted lines are roads. So this is like the roads in your city. They intersect as shown. I want to find the value of x. In this case, I have two angles. One is 2x plus 14, and this one's 4x minus 20. I have one road going straight here and one kind of going off at an angle. It definitely does not look like it's 90 degrees. But what do I know about these two angles? I know that they're sitting on a line. I know that a line or a straight angle measures 180 degrees. Therefore, these angles are what special term that we've just talked about? Well, if they add up to 180 degrees, if they add up to a straight line, I know that these angles are supplementary, which means I should be able to add these together, and they equal 180 added together. So I'm going to take the one angle of 2x plus 14, add it to the other angle of 4x minus 20, and together, angle addition, they add up to a straight line or 180. They're supplementary. Combine like terms, 2x and 4x are like terms, giving me 6x. 14 and negative 20 are like terms, giving me minus 6. That equals 180. I'm going to add 6 here. So I have 6x equals 186. And now I need to take that and divide by 6, and I'm getting 31. In this example here, I have two rows intersecting at what I'm assuming must be a 90-degree angle. And again, if they wanted to prove that to me, they would need that right angle mark. I know that these two angles, or I guess because of this road, they are adjacent angles. Together they make a 90-degree angle. What's the term that we just learned for two angles that add to 90 is complementary. Again, angle addition also says that adding these two should give me 90 degrees. So I'm going to take the one angle of 9x plus 1. I'm going to add it to the 4x minus 2 angle, and together they make up a right angle. They should equal 90 degrees together. Again, do the algebra, combine like terms. 9x and 4x is 13x. Plus 1 minus 2 would be minus 1. That equals 90. 13x equals 91, adding 1 on both sides. And then taking my 91 divided by 13, and I get 7. So complementary and supplementary. Looking at two more terms here, linear pair and vertical angles. Linear pair, the words kind of give it away. You know that the word linear, from last year 100 times we said that means line. So it's a line pair, a pair of angles on a line, in other words. They do have to be adjacent. Remember that adjacent means that they're next to each other. So they're angles next to each other on a line. These adjacent angles, it says, okay, their non-common side forms a line or opposite rays. Meaning, of course, opposite rays are just formed by a line with some point in the middle. The non-common sides, that means there is one common side. here we have a linear pair of angles. This blue angle, or blue arced angle, and this green arced angle are a linear pair because they're a pair of angles that they're adjacent, they're next to each other, they share this ray, their opposite sides form a line, their opposite rays. And what's special about angles in a linear pair? Just like we saw with this last example with these two roads, if these two angles in a linear pair are on a line next to each other, I know from angle addition that these two angles must add up to 180 because that's the measure of a straight angle. What word did we just talk about earlier that means angles that add up to 180 is supplementary. So anytime you have a linear pair, the angles are supplementary because they add up to 180 because they're on a line together, and a line measures 180. Now vertical angles, we're going to be saying this term and using these types of angles all year over and over again. Vertical angles are so important. Vertical angles are formed or found when two lines intersect. So I'm going to draw that right away here. Okay. Now the definition says the sides of vertical angles form two pairs of opposite rays. Remember that opposite rays would be like here and here. And then another set of opposite rays would be here and here. The vertical angles themselves are opposite angles when these lines intersect. So this angle with a blue dot here and this angle with a blue dot here, these are vertical angles because they are opposite angles from each other when two lines intersect. Okay, these are a pair of vertical angles. There's another pair of vertical angles. Every time two lines intersect, there are two pairs of vertical angles because these are also vertical, that they're opposite from each other when two lines intersect. I have a little blank here that they are what? They are special. If you think about any time that two lines intersect, if I knew one angle measure, let's say I knew that this was 130 degrees. Well, what did we just talk about with linear pairs? Let's say we had 130 up here. A linear pair of angles, since they're together on a line and a line measures 180, linear pair of angles are supplementary, meaning that this angle would have to be 50 so that 30 and 150 could add to 180. Well, anytime two lines intersect, same situation. This green and blue pair of angles is a linear pair. They're together on a line. Therefore, if this is 130, this would have to be 50 to add to 180. And wouldn't the same scenario be in place here? I have a green and blue angle together on a line, another linear pair, and if that green angle was 130, then this would have to be 50 degrees. We'll now take a look at a new set of linear pairs. How about this blue and green angle here? Here's a line. Here's a 50-degree angle and an unknown. Well, again, they would have to add to 180 because they're supplementary. They're a linear pair. They're together on a line. Oops, not 180. They add to 180. And this green angle has to, once again, be 130 degrees in order to add to 180 with this 50 degree. Or the same situation is occurring here. I have a blue and green angle together on a line, so once again, have to add to 180. Now, if you notice, what's cool about these vertical angles? What do you notice about both angles marked in green? Well, these opposite angles, these vertical angles are congruent. They're both 130. What about this blue pair of vertical angles? They were opposite from each other when lines intersected. They ended up both being 50 degrees. Once again, they're the same, they're equal, but our geometry term for this same or equal, they are congruent. So super important concept that we're going to see over and over throughout this entire year is that vertical angles are congruent. They're opposite from each other when lines intersect. Oh, and remember how to mark these. If I want to mark these angles congruent, I could do one arc in the blue angles, and then I would have to do two arcs in the green to indicate that they were different size. Alright. In this example, let's identify all the linear pairs and all the pairs of vertical angles. What are linear pairs? They are pairs of angles that make up a line. And again, with linear pairs, you really only want two angles, like you want an actual pair, so you don't really want to name three. I know that that does happen in this picture. But do you see two angles that are together on a line? Does angle 1 have a linear pair? Well, I see a line here, and I could say that angles 1 and 2 make up this line together. So angle 1 and angle 2 are a linear pair. They're together on a line. I see one more set of angles that is a linear pair. they're together on a line. If I look at this line here, I notice that angles 2 and 3 are a pair of angles that make up that line. Unfortunately, there aren't any other sets of linear pairs, because if I look at this line and the other side of it, it was 3, 4, and 5 together, that would add to 180. And we really only want pairs. And if you look at this line and you look at the other side of this line, it's 1, 5, and 4. And again, 3 angles, not really a linear pair. And then, are there any vertical angles? Remember that vertical angles are opposite from each other. When lines intersect, they are congruent. If I look at angle 1, does it have a vertical angle? If I look at the extension of the rays that form angle 1, I notice they do both form lines. Is there an angle opposite from angle 1? How about angle 3? Right? The same angles, the same lines cross and make those angles. So angle 1 and angle 3. A pair of vertical angles, they're opposite when lines cross. Does angle 2 have a vertical angle? Unfortunately, when the lines cross, it would be like 5 and 4 together would be a vertical from angle 2, so in this case I can't really write that one down. So linear pairs and vertical angles. And another example here with 2 angles form a linear pair. The measure of one angle is 3 times the measure of the other angle. Find the measure of each. Wait, 2 angles form a linear pair. Now I know a linear pair is a pair of angles on a line. So I'm going to draw a line, and then I'll put a ray in here because it's a linear pair, so it's 2 angles that form a line. Together they are adjacent. Oh, you know how back here we said that angles in a linear pair are always supplementary, right? I forgot to mention, are supplementary angles always a linear pair? If I go back even further, supplementary angles are any pair of angles that add to 180. They do not have to be adjacent. They could be totally separate, like this example I drew. So supplementary angles don't have to be a linear pair because they don't have to be together adjacent on a line like linear pairs have to be. Anyway, little aside there. Back to this example here, sorry. 2 angles form a linear pair. I drew them here. The measure of one is 3 times the measure of the other. I'm going to have to name these. Well, if one is 3 times the other, if I would just happen to call this angle x, what could I call this angle if it's 3 times the measure of this guy? Well, 3 times whatever that guy is, which is x. So this angle would be 3x. I want to find the measure of each angle. Well, what do I know about this linear pair of angles? I know that these 2 angles are together on a line. I know that a line measures 180 degrees, so if these 2 angles are adjacent next to each other on the line, they should add up to 180. A linear pair is 2 angles on a line is 180. 3x plus x should equal 180 in this case. Well, 3x plus x is 4x. That equals 180. And x should equal 45 degrees then when I divide by 4, excuse me. I found x. It said find the measure of each angle. If x is 45 degrees, then this angle is 45 degrees. This angle is 3 times 45, or 135. Check that these are supplementary, that they are a linear pair, that they add up to 180, and yes, they do. So talking about a lot of special angle pairs today. Last little note is assumptions that you can make from a picture. If lines look straight, they are straight. You can always assume that. And you can assume that if you see a bunch of points, you can assume they're coplanar, meaning they are together on the same plane. Things that you cannot assume. Don't ever think just because segments or angles look congruent, just because they look the same, does not mean they are. The only way you know that segments or angles are congruent is if they're marked. Remember that segments would have to have tick marks in there, and angles would have to have the same number of arcs. So unless you see those marks, don't ever assume that. Don't assume that you have right angles unless you see the right angle mark, and don't assume things are congruent unless they're marked. So angle pairs today.